about differential screws. My first exposure to this was watching one of Tom Lipton's videos where he went over the mechanics of a differential screw. He'd done an excellent job at explaining what they were, how they worked, and I'll put a link in the description box to his video on it. But this was new to me. When I wanted to use threads for fine adjustments and things like that, I just used the finer thread, you know, a 32 thread per inch versus a 20 or 16 or an 18, and then I could get some rough adjustments there. So when Tom had the video showing how you can play the pitches of the screws against each other in what's called the differential screw, I found that quite fascinating, and so I thought I would start playing with them a little bit and just experimenting so I can understand them better. One of our previous videos, you saw that I made this little device, and it's got a differential screw. You got a 1/4 28 thread that goes over here, and a 1/4 28 thread in this piece here. And then this is screwed in, and this is just a coupling device that this is screwed in and Loctited to. And then what we have over here is we have a 1032 thread, and that is hooked in this coupler. So I don't remember off the top of my head, but with the 1/4 28 thread, in fact, I'll do the math on it right here real quick. Yeah, so for every full turn of this unit right here, each full turn, it's going to want to move this device over here 35 thousandths and 7/10. But because I got a 1032 thread here and a 1032 screw here, it's the 1/4 28 is pushing it this way, the 1032 is pulling it back that way, and so what it would do, it'd be pulling this back 31 thousandths and 2.5 So you would have a net gain then on here of about, I think it was, if I remember right, 3.5. Let me see. I got the math. Yeah. So what it would work out to is for every revolution, I'd be moving a certain distance that way, I'd be pulling back a certain distance that way, and it would give me a net gain of 4 thousandths and 4/10. And so when I'd hook up an indicator, again I'll put a link to this video in here, it'd actually come out very close to it. And so in this case, I'll pull this unit apart in a minute so you can see kind of what I built. But basically I have a 1/2 20 thread up here, and down in below on this block I have a 1/2 20, well actually a 1/2 20.16 thread. And that thread that I have down here, the way I got that is I used a CNC lathe, and I just programmed in the numbers, and I don't know how accurate and how many decimal places that CNC lathe would be able to accurately give me that 20.16, but I thought I'd give it a try and find out. So basically I did the math with the amount of adjustment that you would get out of a 1/2 20 minus, or add in, depending on which direction you're going, of that 1/2 20.16. For every revolution, what I was shooting for was 4/10 adjustment. Well, as you can see in here, I don't got the 4/10 adjustment. I have about 2.7. And there can be a number of factors. One, the threads are just machined. They're not ground threads. This pin, the unit that I got the outside threads on, the 20.16 threads and this 1/2 20, I cut those a piece of steel that was 5052 Rockwell. So it's a hard piece of steel. This is soft Cobra. I just ran a 1/2 20 tap in here, and I have a little bushing in here that was soft, and I used a different internal thread tool to cut the 20.16. So I think maybe that the accuracy that I would have is probably not an exact one, because I'm trying to machine these threads and trying to get them exact rather than grinding them. And so there's different pressures cutting hardened steel. I was using different inserts, maybe the angle mesh up was different. But the thing that's amazing to me was I still got a fine adjustment, actually finer than what I was shooting for. And not only that, as you saw in the video, as I'd repeat that and come back down to zero, it would repeat real nice. Now, there'd be a couple times that I would turn this, and then I might not quite get to 2.7, it might be 2.5 or closer to 3. That could be in the mechanics, you know, because I just made a cheap, dirty fixture on here. It could be some of the variables in there. It could be some of the variables in the threads. There's probably burrs on the edges that, I mean, to the naked eye look good, but if you look closer, you may find some of that. But anyways, that was a demonstration of a differential screw. And I'll show you the reason why I'm looking at a fine adjustment. And I think I mentioned it in one of the other videos that we want to build us a fixture we can put on the surface grinder so that we can grind between centers. And I'll show you over here on the computer. Okay, here's part of the design that I got started. And this will be the tailstock end, different pieces with the center, a dead center over here. This side will be the motorized, and then I'll be able to have the adjustment going up and down. But what I wanted to do, I wanted to have at least a two-part, maybe more over here, so I can have a fine adjustment, excuse me, because you need to have a way to take your taper out, because you're always going to end up with a little bit of taper. And when you grind between centers, if you got good centers, you can get some of your best, most accurate grinding. And so if I need to take a tenth, say if I got a part that I'm grinding and I have a tenth taper in it, that means I need an adjustment of about 50 millionths or less. So I need something that I can have a fine adjustment, because if I got a tenth taper, I need to take half of that from each side. As I raise 50 millionths, that's going to make the tenth difference. So again, I need something real fine adjustment. Now some of these devices, because they're such fine, they'll just have a flexure point on there, and then they just kind of angle the center. Well, I want my center to remain, the center lines between them to remain true, and just be able to raise up and down. And so just some stuff I'm kind of horsing around with, playing with. And I got some different concepts that I'm looking at over here. One of the things that I'm looking at right here, I can have my center mounted over here, but I can make a couple blocks, and this will be kind of a fun little project. But you know, I'm only going to have to adjust probably less than 10 thousandths, so getting something that interlocks like that, and machining and grinding that and getting it all matched up is going to be kind of a little bit of a challenge. But I think it'll be a fun little project. Things will interlock, and that's just kind of a rough design and concept that I'm doing now. Now with the differential screw, that adjusts pretty nice, but the problem is, as you saw in the video at the start, as that screw adjusts, I got to have quite the length for the screw to adjust, because one is pushing, one thread's pushing, the other's pulling, but yet that screw's moving quite the distance. And so I'll be limited to how much I could do, and I was hoping that I could just get about 4 thousandths each direction. So another unit that I'm going to play with, and it'll probably be a future video that I think probably is going to work better, and I'll probably go that way. I'll have a wedge system. If you do the math, you can take a system like this. I can have a screw sitting on this end pushing at this wedge. I have this one drawn at 4 degrees so you can see it a little bit. It's actually, here's your flat surface, a flat surface. Here you got an angled surface, and you got an angled surface there. But if I would use a 1/4-20 thread, every revolution that would push this wedge in 50 thousandths. And then what will happen at about just a little less than half a degree, that would raise this block up about 4/10. The nice thing about this is if I want to add another wedge, say down here, have this wedge, I can have this one add just a hair under a half degree. I can get that extremely fine adjustment. I can have another wedge over here at about 4.5 degrees, and then for every revolution that I go up, I'm going to go up 4 thousandths. So I can have a coarse adjustment with a wedge system down here, a fine adjustment there. The other nice thing about that, if I want to make it even finer, the blocks that I have mounted on the back that will have the threads for the screw, I can start with 1/4-20, and if I wanted to go even finer, I can put 10/32s. I can, if I want to go coarser, I can go 3/8/16s. I can use just some common threads, and each of those will move that block a different amount per revolution, and it will change the type of resolution that you're going to get. And so I'm going to, in the future, work on a block like this, and hopefully we'll see how it works. We'll compare it with the differential screw, and then I'll make my decision on which way I want to go with it, and hopefully we'll get that tailstock good. And like I say, this whole project of making that queen center fixture, it may be a 6-month process, I'm guessing. We'll go from there. There's a few other things that I want to mention, but let's go back and let's pull this thing apart so I can show you kind of the construction that I got going on here. Let's get the wrench in there. Now a lot of these projects that I use, I won't use some expensive tool steel. I go down to, we got a steel company that's right here in Holland, Harbor Steel, and from time to time I'll go in there, and what I'll do is I'll buy co-roll because it's quite a bit cheaper than tool steel, and then I can do all this testing, these projects. And so even with these pieces, it's all co-roll on there. I'll throw these on the shelf. I'll use them for future projects like this that I'm testing. So I just recently ran down to Harbor Steel and purchased about $100 worth of co-roll steel. I'll do that probably about once a year because it's just nice to have some of that on the shelf. And the nice thing about having Harbor Steel, and I don't know if steel companies in your area would do this, but if you have to buy some of the steel and you have to have them cut it out of a bar, what's going to happen is you're going to be charged a cut charge. And so at Harbor Steel, they got random lengths, and what's nice, you can go in there and you can just see some of the random lengths. These were bars that are shorter. They're leftovers from other customers making cuts, and you can get these random lengths, and they may vary from just little 6-inch pieces to 36, maybe even taller. You can get a lot of different lengths, and in fact, let me show you what I just picked up over here. I'll carry it over there. Here's the pile of steel I just got from them, and these were all random lengths. And so what would happen is I don't have to pay for the saw cut, and so that works out real nice. You can save a lot of money that way. When I posted on Instagram some of the people follow me on Instagram, they mentioned that they got scrap yards in the area, and we have a few too around here, and that would be another good source where you can go in there and probably get some of these chunks of steel pretty cheap, so you don't end up investing a lot of money in a project. You can take some cheaper steel, test it out. One of the things with cold roll steel that you got to watch for, though, is there's a lot of stress built up in the steel. And that's true with hot roll too. And so when you cut this, that steel will actually, sometimes if there's a lot of stress, you can see it moving. And so one of the things you want to keep in mind when you're cutting this steel, well, there's a couple things. Just give you a couple pointers. When you're cutting this steel, and again, the longer pieces, you'll see that stress more and more. But when you cut this, let's just say that you got 100 thousandths total that you want to take off on this thickness. Well, what you want to do, you want to make sure you cut both sides, and you want to cut equal amounts. And so you want to rough it and then finish it. So if I have 100 thousandths I want to take off, I want to take 40 off this side, flip it over, take 40 off this side, and it will stress back and forth. A lot of that stress, if it's in there, it will release. And then you come back and you finish it, taking 10 thousandths. And that way you can work a lot of that stress out as you're cutting it. And you do similar operations when you grind it. Now sometimes there's so much stress in there, you just have to throw the piece away. I've ground pieces already, and you can actually see the stuff moving on you as you grind it. You can send it out and have it stress relieved or normalized or whatever, but a lot of times at that point it's kind of too late. So when you're machining a piece like this, it's always good too is if you take a cutter that will cut the full width of this as you're coming across. If you take just a regular end mill and you're cutting half of that, well, stress is relieving out of that, but not this side. So you're getting some twist and stuff. By having a cutter that's big enough that covers the entire surface, it works a lot nicer, and again, you can work around the stress there. But that's just some pointers on working with cold roll steel, hot roll steel. But I just made this unit right here to show you what I got going. I'll pull it apart. So I had the 4 blocks that I can mount to this one right here. That would help guide this because I only have a 1/4 20 thread. I got 2 1032 screws with springs. I'll show you in a minute down here. But I wanted this block, this movable block, I wanted it to guide real nice. And one of the things that I knew as this was going up and down, I got springs down here. I got probably a light contact on here. I knew I might get some drag issues with that fine adjustment, with that 4/10 too. So what I did is I ground this block about 1/10 smaller than that to try to eliminate that. And so if you look in the bottom, I don't know if you can see inside there, but I have a bushing inside here that's screwed in. And over here I got 2 spring-loaded holes because I wanted to have the spring pressure to pull the part and always keep the tension on the same side of the screws. Because with the threads, you know, there's going to be some slop in there, and I wanted to make sure that that wasn't messing up my. So I put just a couple die springs in there, and with the screws, and then that would always keep tension, so that when my adjustments, I'm always staying on one side of my threaded screws. And with these fine threads, they take a while to coming out. But basically, this is the differential screw. This side right here has a 1/2 20 thread. This side right here was machined on the CNC lathe, and it's a 1/2 20.16 thread. Now I was getting on an average, as testing this, I was getting about 2.7 tenths per revolution. And I did the math on that, and that would be a 20.16 thread. And so that would be basically, if I was shooting for that and I'd get an exact reading, that's what it would be. So again, I don't know if there's limitations on that CNC lathe that we have as far as when I plug in on the thread per inch, when I plug in 20.16, if it could even get that fine of a resolution. If it rounded off to 20.1, I don't know. I used a different threading tool for the OD than the ID. There could be mismatches there. There could be a lot of variables that are at play there. But anyhow, that's the concept between the differential screws using different threads on both sides to achieve some of that fine adjustment. Robin Renzini, he's got a video on using differential screws for making, and he's using them in a different way, not for fine adjusting. He's using these for fixing his vice jaws on his vice so that he can replace them real quick. And I'll put a link to that video too, and it'll show another use of the differential screws. So anyways, that's what we have over here. And I just want to talk a little bit about some upcoming things that will take place. We've been invited to Bar Z Summer Bash, and we've never went to one of these type events before, so we want to give a big thank you for Stan for inviting us, and we're planning on going. It's an event that'll be towards the end of June, and so that'll be a new experience for us. We're hoping that some of our subscribers and the viewers, some of the YouTube creators, being able to meet some of you guys out there, that'll be kind of nice. We communicate, you know, over the YouTube forum like that. I've had phone conversations with a few of you guys, and it's kind of exciting with this medium or this format of YouTube, being able to meet other people in the trade and being able to learn. And so anyways, a big thank you for Stan, and I hope that we can see a lot of you guys there. And I want to show you something else with the YouTube community, how good this is. A couple things just in the past, recent past that came up that I thought was really neat, and I want to share with you. So we're just going to go back over by the computer here. Well, there's a few things I wanted to talk about over here. One, when I go and watch other videos, a lot of times I like to read the comment sections, and I'm finding myself spending more and more time on the YouTube videos, less and less time like TV and other entertainments, gaming. But anyways, that was kind of a pleasant surprise when I was watching a video here, one of the last ones that Stan did on grinding wheels and mounting and balancing. After I watched the video, I just started looking at all the comments that he was getting, and as I was scrolling down through here, here's an individual that Rupert Powell. He was asking Stan about high-speed wheels. Looks like he's going to be building a high-speed spindle for, I assume, ID grinding using stone wheels. And his spindle is going to go about 60,000 RPMs. Well, a lot of these wheels are rated at about 40, 45, 48, something like that. So he's asking Stan some comments on the speed. And so as I'm reading through this, we can see that Rupert's got a sneak peek of this high-speed spindle, what he's going to do. And so Stan tells him to make sure in this comment, you know, that the wheel's rated for his RPMs. And then he told him to check out this channel right here for a bearing mount. Well, at the time, I didn't know that was one of the videos that we've done on our high-speed spindle that we hooked up to the surface grinder. But as I was reading down through here, and then Rupert's talking about some of the RPMs that wheels are rated for. And then he comes up with this comment. He says, "You're right, I should ask Steve for some advice. He's the man. I just did a video on something Steve Barton inspired me to do." And then right away I thought, whoa, how did I get in the mix here? And, you know, so obviously that would catch my attention, and then I'm wondering, what is it that I inspired this guy to do? And so he actually had a video that he brought up. He goes and says, "Hey, I hope you don't think I'm trying to hijack your show, but I need the subscribers well short of my 1,000, unfortunately. YouTube has come out with a new policy if you monetize, and then one of the things you have to have 1,000 subscribers, and so there's a lot of people out there that are trying to get more subscribers. And I watch a few of Rupert's channels. I subscribe to his channel. He's got some good stuff on there, but the video that he was doing was on this device right here. We did an earlier video where it's on a depth mic, an electronic one using an indicator. Now this one has a 50 millionth resolution on there, and you can set this, you know, at the up range for 0, and now you got a direct read. And so anyhow, he bought him a similar indicator, and he needed a foot on there. So he machined his foot out of that on that video, and he's showing how he machined that and putting his indicator. And so this is what he was talking about, and it's kind of neat because we got some projects that are going out here pretty soon where we got to have some heat treat on some CPM1V, and because it's kind of expensive and they have a minimum charge. One of the nice things about watching Rupert's videos on there, Adam has an indicator similar to this, but he doesn't have a foot, and so we're looking for projects that we can do as well, you know, to get up to our minimum order. So we're going to take some of our 1V and make a foot for Adam's indicator, so that's something we didn't think of until we watched Rupert's video. So we'll be doing one of those. Another individual that I subscribed to lately, his name is Richard. It's Making Something from Nothing. I'd encourage you to check out his site as well. I'll put a link to that. But I just want to bring him up for a couple reasons. One, he's doing a really good job. He's got a mini lathe and mini mill, and he's self-learned. And most of the stuff that he's learning, he tells me he's getting from YouTube creators and comments that are people. He's learning this trade on YouTube, and it's really amazing to see how well he's doing just by learning from what others are doing. And I think the YouTube's a great community for learning some of this stuff. We got some great creators, got some great subscribers, great viewers, and so you can learn as much if you go through the comment sections a lot of times as what you see in the video. There's a lot of good stuff. We've learned, well, we applied a number of things with our coolant system over there, using if our earlier videos you can hear that our pump was really loud. I think it was DJ Berg. I hope I'm getting the names right. He talked about using one of these pond fountain pumps, and so we bought one of those. Now the coolant's nice and quiet. And then we, in another video, you know, we were talking about getting all the garbage out of our coolant when we're grinding these bit stones. And so Greg Kojak, he talked about using these filter socks, and so I started asking about that, and next thing you know, we're adding that to our coolant tank. So from our viewers and subscribers, we had some nice input. It got our coolant system a whole lot nicer, and we didn't have to put a lot of money in it, so it worked out good. So anyways, if you're going through there, check out some of these comments. Be sure to check out Rupert, his channel. Check out Richard, his channel. And one of the things that I want to show you too, when we go to the summer bash, one of the things that we're waiting for right now, this is all CPM 1V, all these projects. This is what we get ready to go. Some more setup blocks that I'll use with my cube. But I'm making 4 more of these low profile sine bars. And my original plan was make one for myself, make one for my son Adam, and then we have Gary Walters. He's helped us move equipment in here. We have Bruce DeBoer. He's helped us with pouring the cement. So we were gonna, you know, make one for each of those guys for thank you. For thanks there too. But anyways, the one that I was going to build for myself, I will be bringing that out to Barzee in the summer bash, and that will be used, you know, for one of the giveaways, the prizes. As well, we're going to try to make a few of those double-ended indexable boring bars and bring those as well for gifts. And so anyways, that's going to be it for today's video. We hope you enjoyed. And if you can make it to Barzee Summer Bash, I'd sure like to meet some of you guys in person. It'd be pretty neat to be able to just have conversations with some of you guys. And so we'll hope to see you there.